Thanks everybody for coming. We're going to talk about dirty dancing. How can we make some untrustworthy SLSA build provenance? And I know that I'm going to be keeping you all from really great conference lunch, so try to make sure that I finish on time. All right, so a little bit about me. I'm Kjell. You saw me up here earlier, consultant at ControlPlane, two-time college dropout. So, I like to set the expectations low at the beginning of a conference talk. You know what you're getting into. I'm also an open source maintainer for Witness and Archivista, which will be in the talk today, part of the SBOMIT community and the update framework. Also a co-chair with a few other people around here for tag security, and love all of the things going on in CNCF and OpenSSF. So how many people here are familiar with SLSA generally? All right, so this is the favorite picture of everyone who talks about SLSA. This is the one from the website, not one rebranded with a company's color scheme, because that's also great to see. Today we're going to be looking specifically at some of the threats in the D, so kind of in between really the inputs to the build process itself. And so looking at these, what are the threats about the external build parameters? You can see issues with building from an unofficial fork of the code, an unofficial branch or tag, and the mitigations for each of these things say the verifier should do some of these things to check and to look and make sure that your expectations meet reality. And the same thing here. Unofficial build steps are the workflows or the build processes that are being passed into whatever it is building the software, what you expect them to be. And the parameters, so kind of really understanding this entire process that goes into it. And this last one here is actually part of the next part, which is the modified version of the source code. So did it get modified after the checkout? And they put this on the build platform, which is an interesting thing we'll see when we get into the examples of pulling it directly from the source repository. And that's, in the case of GitHub Actions and workflows, the boundary between the build platform and a maintainer of a project gets a little blurry sometimes. All right, so let's build some things. Here we have, GitHub makes it really hard to take screenshots of this, but a simple little project. It has a build step, and just to simplify things, it's going to create two different SLSA build provenances. One is using the SLSA GithUb-generator, so you can see the kind of the top horizontal line there. It does some things to detect the environment, actually generate the provenance, and then publish it. The bottom one here is action that uses GitHub's new attestation actions, and so that's kind of the two different tools that we have here. And you can see at the top, this is tagged as version 0.0.3, and just to kind of show here the workflow itself. So this is the provenance where we need the build step in order to generate this. We're going to need some permissions to be able to create the signature with SigStore, so we need the ID token. And since we're in the case of the SLSA build provenance, we're going to attach this to the container image, so we need the right permissions for the packages. And then we provide the inputs to be able to create this. So in this case, we're taking the image output, the digest of the image that's created, and we need the registry username to be able to push. And this is the GitHub attest workflow. You can see it actually doesn't need the package write, because in this case it's going to write to GitHub's native attestation store, and we'll see that. And then the same sort of thing. We're going to pass in the subject name and the subject digest, and in each case those are coming from the build output or the parameters to the build. All right, so now we'll go ahead and try and verify this thing that we have built. And so this screen gets a little bit small. We'll try and do it live, assuming that the network connection works all right. And make this. All right, so what we're going to do here is first try and just use the SLSA verifier, and you can see here we're passing in the builder ID. We know that we built v0.0.3. The repo that we used here, this is public repo, you can go and see it, and the source tag as the input. So we'll go ahead and try and verify this, and the first really great thing we get is an error, because we shouldn't be verifying with a mutable tag, so let's not do that. And so we'll go back to this here, and we'll verify with the digest of the container image. We can see here the long digest. We can see verified using the builder, and we see the SLSA framework GitHub generator, and then the GitHub workflow generator container SLSA 3, and then the reference to the tag v2.1.0. There's some comments in the repo itself about how reusable workflows work in GitHub Actions and why this is a tag and not pinned to a digest, but that's a longer conversation. And then you can see the commit that was verified as a part of this. So this commit should match with the source tag of v0.0.3. And just to make sure that everything else is working on the GitHub side, this is built into the GitHub CLI itself. So we can do GitHub attestation verify. In this case, the owner is the repo. So this is my repo under Kjell. And we're going to look at verifying an OCI image and the v0.0.3. And we'll see if this works. All right, and so we get a lot more content here. You'll see that they actually accept the tag, but they do print out here what the digest is. We see the 627 ED, which matches the 627 EDF that we had here in the previous one, so that's good. It loaded one attestation from the GitHub API, and we get the sorts of things that go into essentially the policy that GitHub uses in order to verify this. So it expects the OIDC issuer should come from tokens.actions.github. The repo matches the subject alternate name, and it's a SLSA provenance. In this case, we can also see some other contents here down at the bottom about the build repo and the workflow, and the signer repo and the signer workflow there. So everything is good. We should be able to go ahead and run this container image that we created. And all right, it says it's time to do the dirty bird. Any Atlanta Falcons fans? But there's just one slight problem with that. We come back over here. And in our source code here, it says print hello world, not it's time to do dancing. And how can that be? We can see this is from the same tag, v0.0.3. What has gone wrong here? Everything is signed. The provenance is not supposed to be forgeable. We verified everything. The signatures match up. What happened? So let's look and see what the details actually have in here. And so there's some really great tools to kind of dig into the details of this here. OCI.FYI, if you ever want to navigate images, Billy was around here before. He created this. It was really cool to be able to see, here is the container image we're using, and it doesn't have any signatures. I like to call signatures empty attestations. So if we have attestations, hopefully we can make better use of those. In this case, we can see all the information that's in the attestation itself. It matches up with a lot of our expectations. And here we can see the SHA of the git commit. So if we look at this here, we can see this matches what it showed in the SLSA verifier. So what's happening? Also, if you want to go another level deeper, you can look into the actual contents of the manifest and see how the signature is attached. And this is using the newer cosign bundle format. And you can click through and actually go all the way to looking at the attestation itself. And there's also the certificate in here that you can see. And one of the really cool things about this as well is it gives you the crane commands, the CLI, so you can use crane to pull down this manifest, JQ, and things like that, and then the OpenSSL decode. So this is part of how SigStore is actually signing this. And we can see references in the signature as well using the token from GitHub, and it has the same digest here. In the GitHub UI, it's kind of a hidden little thing. If you go to any repo and /attestations, you can see what sort of attestations they have in there. So here's a whole set of attestations for this repo, and we can go in here to the v0.0.3 and see the command for how we want to verify, which is nice. But once again, we see the commit digest is the same thing that we're seeing in all of the other places. But that's not the code that's actually being built. And so in my workflow, you can see here, the very first thing that happens is we check out the repository. And when we do our checkout, we pass in a reference to a branch rather than building from main. And this is one of those things where you shouldn't do this. You shouldn't be having a release workflow that isn't building from the branch or the reference that you expect it to. And the SLSA build provenance, in the case of the SLSA Github-generator, actually tells us from in the metadata under completeness that the environment and materials are not necessarily complete. And this is how the generator works. It's taking it from an external source and just passing it in as a parameter. It's not observing the build process itself. So this is how we end up using different source code. All of the identity of the workflow is tied to the commit of the workflow itself and not necessarily the contents of that. So when we think about what we want to verify, we really need to make sure that we think a little bit deeper and not just take the default assumptions about these higher level properties. Just the fact that there is a build provenance doesn't mean that we should trust it. So we're going to add in an ability to actually observe the build process itself. This is one of the projects that I'm a maintainer on, Witness. And there's a GitHub action for Witness run. We have the concept and ideas of different attesters. And so in this case, we're going to use a GitHub, an environment, a Docker, and a SLSA attester, and use this to actually wrap around the build process itself. And when you run this, at the end, you'll get, in the result of the GitHub Actions workflow, a link to the attestation. This is stored in Archivista, similar to how GitHub stores in their own attestation store. And this is what the attestation looks like itself. So it has, rather than just one attestation, a collection of attestations. And it has details in this about the environment, the Git repository, GitHub, all those parameters that we set up before. And we can see in this, by capturing those additional pieces of metadata, we actually have, right before the build process, right before that command executes for the Docker build, we locally inside of that step look for what the commit hash is. And so here we can see something different than what we saw everywhere else. And it also is capturing the branch and the references. So down here at the bottom, we can see it's pointing to refs/head/dirtybird instead of main. And also, when we then generate this SLSA provenance, we're providing the corrected digest of what's built, what's passed into the container image build step itself. So let's try and verify this all over again. So we're going to go ahead and use a witness policy. And in this case, we can see when we go through and try and do this verification based on the policy, we're going to have requirements about the Git attestation that it should be built from the main branch. We kind of know that about this release process. The tag should always be on main at that latest point in time. And so then we're essentially go through, take that ref in the git clone step, the actions checkout step, so that we actually build from main, and then we're able to successfully verify. And when we run again, we get hello world. So we can take a look quick at the policy itself as well to kind of see what that looks like. And we can see essentially all we have to do is define the types of attestations that we expect. So in this case, we're expecting the Git attestation, the GitHub attestation, the SLSA provenance, and the container image. When we, for each of these different types of attestations, we can have rego policies. And since they're embedded in this, we actually have them base 64 encoded, because who doesn't love base 64 encoding? But decoding that, looking at what the rego itself, is really simple. Essentially, for the Git attestation, we're going to deny if the input branch is not equal to head. And so you can make this as complicated as you want to. That's more than I wanted to do for today, and it's already a lot to take in. For the SLSA builder itself, these are also some of the options and parameters you can have for the GitHub verifier and the SLSA verifier to really check and make sure that, in this case, we're using the witness.dev SLSA build definition, and for our builder ID, we have the witness GitHub action builder. So we're checking those things, making sure that all of that aligns with the expectations. All right, so now we have a better way, a more complete way of verifying everything. What else should we do? And this is an interesting part of the build process itself that took me a long time to kind of wrap my head around. And that's this idea that in the threat model, forging the output digest of the provenance is NA. It's not applicable. It's not a concern that SLSA covers. Why is that? Essentially, if you're a compiler, anything you pass into that compiler could result in any output. You don't, unless you are a compiler yourself or you can predict the future, you're not going to know based on the source code that you pass in, the dependencies, everything else, what that result is going to be. Otherwise, you probably wouldn't need to compile all of that code into something because you already know what the result will be. So what do we do about that? So there's a talk later today that you should go and see from Alice at NYU. They've got some really cool projects they're working on to actually kind of prove out that what you expect to happen in the build process itself happens. Also, there's one of the really cool things about OpenSSF is they actually have money to support stuff like making better tooling and improving it. And so there recently was a funding request put in by Hayden, who's here, to help modernize and improve this tooling. And the other thing is Puerco just gave a talk about in toto and policies, and it was different than this one. And he was using different tooling. And there's another talk this afternoon about how to build interoperable tooling. We're all using in toto for the attestations. There's slightly different formats for different things, different predicate types. How do we make sure all of these tools work together so that you all, as consumers of these tools, don't have to go through really hard choices and trying to figure out what we should do when and where and how. It's already complicated enough without the tooling making it even more complicated. And you should come and get involved. Every week there is a SLSA specification meeting. They're meeting, I think, right now or in a half hour, if anybody wants to join. And there should be probably today a new blog post going out about the next RC candidate for the source track. So that would be awesome. And with that, I think we have a minute or two if anybody has any questions. I know that was a lot to take in.
So we saw that the attestations and the policies are very powerful. But can you speak a little bit to how we can validate the integrity of the policies themselves and the best practices?
That's a good question. So the question about how to validate the integrity of the policy itself. So the policy is signed. You have to kind of out of band understand the signature that wraps around the policy. But really understanding whether or not the semantics of the policy are correct is a really hard thing to do. When I was sort of developing this policy, it was really a question of how to test it and ensure that the expectations I have, if I change a reference or I change a digest, does the policy fail? Now this is really hard to scale, right? If you're consuming 1,000 open source dependencies and they've all published a SLSA Build Provenance, how do you understand what the policy should be for every single one of those open source projects? They all have their own way to build this. They all have changes that will happen over time. How do you keep up with all of these things? How do you ask the maintainers what the right way is for things to have been built? This is a problem we need to solve. So if folks are interested, once again, come to these meetings and conversations, and happy to chat throughout the entire week. So.